Okay, for total distance traveled, remember, from 0 to 3 seconds, if this is the velocity function that represents the velocity of a particle moving in straight line motion, with right being positive, left being negative, that means that whenever this thing is negative, whenever this function is negative, then it's moving to the left. Whenever it's positive, it's moving to the right. So to get the displacement of the particle, we can integrate from 0 to 3 this function. Okay, but to get the distance traveled, we need to take the absolute value of any negative, any left movement, and add that to any distance traveled to the right, which means we're going to have to figure out when this is positive, when this is negative. Okay, so I have a hint you can factor by grouping, so we're going to factor it to see where it crosses the x-axis. And I get x squared minus 1 times the linear factor x minus 2, and I get x plus 1, x minus 1, x minus 2. Okay, that means the intercepts are at x equals 2, x equals 1, and x equals negative 1. Okay, so we just have to worry about these two guys, right? Because that's in our interval. So in other words, the distance is going to be given by, I'm going to integrate from 0 to 1. And then I'm going to integrate from 1 to 2. And then I'm going to go from 2 to 3. Okay, now there's a couple ways to go from here. We can decide when this thing is negative and positive, which wouldn't be hard to do. We can just do some test values in between, kind of like the first derivative test, only just to test if the function, the velocity function, is negative. So we could do that. Or we could not even worry about it and just figure out what these are, and then just take the absolute value of all of them. In other words, if one of them is negative or if two of them are negative, just make it positive. Okay, so let's see. This is going to get a little long. So let's give myself a little more room to do this. And that would be the antiderivative of this function is going to be, so this guy is equal to x to the 4th over 4 minus x cubed over 3 times 2 minus x squared over 2 plus 2x. Okay, and then I got to do that 3 times. And if I get a negative, I got to make it positive. Okay, so the first one we could go from 0 to 1. And then I'll just rewrite it. And then from 1 to 2. And then again, a lot of work. From 2 to 3. Okay, and either it looks like that either two of these are negative, right? Because it's going to cross at this x value and this x value. So either two of these are negative or one of them's negative. It should be. So I'll continue to do this. All right, so now we got to plug in some values here. So how much work do we need to do? So I'm going to plug in 1. So 1/4 minus 2/3 minus 1/2 plus 2 minus 0. So we don't really need that one. So there's my first one. Plus 2 to the 4th is 16. So that's 16 over 4. And then that should give you 2 to the 3rd is 8 times 2 is 16. 16/3 minus 2 plus 4 minus, plug in 1 here, And you get the 1/4 minus 2/3 minus 1/2 plus 2. This should be 13/12 if we did the math. So this will be 13/12. Okay, and again, absolute value. This one I think is the negative guy. And then we'll do this all over again for the last one. You get 3 to the 4th over 4 minus 2 times 3 to the 3rd over 3 minus 9/2 plus 6. That's what I get when I plug in 3. And then minus, I'm running out of room. So I'm going to subtract from that if I plug in 2. So it'd be 2 to the 4th over 4. Oh, that one we did. Maybe we can save ourselves a little bit of trouble. Just a little bit. And then do the computations at the end. So now I plug in 2 and I should get that guy. Right? So that would be 4 minus 16/3 minus 2 plus 4. Okay, so this is one definite integral. This is my other definite integral, and this is my first definite integral, and we would just make all those positive. So I got 13/12 for this one. This one's going to be negative. I get a negative 5/12 here. And this one's 37/12. Add all those together, 55/12.